Okay, so I see we're live, so I think we can start. Um, so this is section 6G CPS Explore, and we will start with the work of Zafer Duzen, Mirella Riveni, and Mehmet S. Aktas, Processes for Misinformation Spread Analysis on Social Networks, a COVID-19 case study. Zafer, I give you the podium.
Okay, thank you very much.
Just
Sorry.
inform me, you have 15 minutes and then some time for questions.
Okay.
I will notify you with some signaling when you're close.
Yeah. I will try to do that. Okay. Thank you very much. This is Zafer Düzen. I'm joining from Istanbul, Turkey. I'm a PhD student at Computer Engineering Department at Yıldız Technical University, and I will try to present my ongoing study, which is related with uh, process for misinformation spread analysis on social networks. And it's a COVID-19 case study. Okay, let me jump the. Okay, this is my outline. I will start with the introduction, then some research questions, and I will try to explain my related work, my proposed methodology, then evaluation and conclusion. Okay, this is the introduction part. For the introduction part, in recent times, you already know the world has been grappling with the unprecedented COVID-19 pandemic. Alongside this health crisis, we have witnessed an alarming surge in the dissemination of misinformation across various social networks, particularly on platforms like Twitter, Facebook, or YouTube, or something like this. And it is within this context that my study aims to shed light on the process involved in the spread of misinformation, and with a specific focus on analyzing the role of non-trusted accounts. So to accomplish this, finding misinformation, we have designed a data analysis process that leverages social network data such as retweets, mention, and replies to examine the factors contributing to the spread of misinformation on the participation of non-trusted or fake accounts on the Twitter. So we have developed a prototype tool based on this process and conduct an experimental study using COVID-19 related Twitter dataset. So, 1 minute. Let me go to the other page. Okay, let's jump to the research questions. For the research questions part, for the research questions part, my first question is, we are trying to find how can a process supporting software architecture be designed to effectively utilize social network analysis metrics and algorithms for detecting misinformation spread. As a second question, we are trying to find that how can the proposed process architecture be implemented in a prototype software application for detecting COVID-19 related misinformation using social network analysis metrics. And my last question, which we are trying to find, is uh, what kind of valuable insights can be gained from this analyzing this kind of data. So, as for the 1 minute for the related work, there are lots of people are working on the misinformation uh, or that kind of fake accounts, misinformation, spread disinformation. Actually, these studies are began at the, I think, 2016 presidential election of United USA. So at that time, the Twitter and Facebook is used too much for this misinformation spreads. So people are working on this kind of studies, and there are lots of machine learning techniques have been employed to predict links and classify disaster-related tweets, aiming to identify and counteract misinformation. There are lots of COVID-19 datasets like CO8, recovery, and fake COVID, which people are working on them. And there are lots of concerns, also privacy concerns, demographic considerations are taken into account when people are working on this kind of problems. Other than that, some research efforts have focused on examining the impact and effectiveness of fact-checking initiatives in countering the false information. By studying the relationship between misinformation, fact-checking, and network data, valuable insights have been gained, shedding light on the dynamic nature of misinformation propagation during outbreaks. So, let me explain our proposed methodology. Our proposed methodology is consists of some modules, and I will try to explain one by one. Uh, Actually, our proposed methodology comprises several interconnected modules that form a software architecture capable of effectively analyzing and leveraging this social network data. The first one is data collection module. The module utilizes the Twitter REST API to collect Twitter data, including tweets, account, and other relevant information. The second one is the data pre-processing module. After we collected the tweet, then we are processing them and converting them into comma-separated values format, ensuring the compatibility with subsequent modules. And then we are extracting the key details from this CSV file, the mentions, replies, and retweets, which are vital for our network analysis. Then for the data annotation module, and when we, okay, for each day, maybe 1 million tweet is downloaded for the analyzed date. So we need to find a way to annotate the tweets. This could be a misinformation or not. So we are using some websites, some credible websites named IFFI News or that kind of things. And we are trying to label all the tweets uh, if they could be misinformation or not, and we are trying to find that from, is it sent from an uncredible account or not. And then the output of this module comes to network creation module. Our network creation module constructs some social network graph using retweets, mention, and replies. Individual usernames are represented as nodes in the network, and the interactions between these usernames are represented as edges. Then it's creating a comprehensive network model. After that, we have another module named centrality calculator module. This module calculates the centrality metrics, including the degree centrality, closeness centrality, and betweenness centrality. And these metrics help us to identify the influential nodes for that day within the network. So we are trying to find the specific users which can lead to spread of misinformation. And then we are having another module named community detection module. For each day, we already extracted networks, and from each network, we are trying to find the communities. And by utilizing community detection algorithms, it groups nodes that exhibit dense connections within specific communities, enabling us to gain insights into how misinformation spreads within different groups on social media. Then a last module is coming role, and it is the misinformation detection module. It analyzes the user and tweet pairs within these communities, comparing their centrality metrics to identify influential users who may be spreading misinformation within specific communities. Okay, this is our proposed architecture. Then let me explain our dataset to you. Actually, we are using an ongoing research named COVAXI. This COVAXI dataset monitored and analyzed by a group named Osome at Indiana University. And they are collecting English tweets related to COVID-19 vaccination. It's 1 year research, and for each day, nearly 1 million tweet ID is there. So we try to download that data within the Twitter APIs. Actually, the dataset covers the period from January 2021 and January 2022, and it's obtained by daily queries using this specific keywords. The vaccine gave you this kind of keywords are used, and then we are using the Twitter API and the tweets lookup REST endpoint to query the tweet collection based on their IDs. They are sharing the IDs with us, and we are trying to download the tweets from there. And when we are trying to download a tweet, we are trying to get the information like this: the field values, the authors created it. We are collecting lots of metrics and information from the user. And as you know, some of the users in the Twitter can be blocked, or they could be private user after some time, and maybe they can delete their tweets, and that could be a problem when we are downloading. If when we are downloading the tweets, if the response point data is coming as a response, then it means we can get the tweets. Else there could be an error, and also if we need an additional properties, we can use this response.includes property. And the data is something like this. We have author ID, created language. There are lots of metrics in it. And this is a big data. For 1 day, we are collecting maybe 50 gigabytes data for only 1 day. And then, 1 minute. Okay. I think, okay, let's talk about our prototype and evaluation part. Actually, we also created a graphical user interface, and in this graphical user interface, we can select 1 day downloaded data, and then we can create some networks. Then we can show that network info to the user. Then we can find the communities, calculate the centralities. For each module, we have a button in the graphical user interface, and we can show the user like this at the end. For the calculation of this kind of information, we are using Python libraries, we are using NumPy, Pandas, and for the visualization, we are using NetworkX and the Gephi applications. And then for 1 day, I can show you what we have found. And actually, we studied on the day of the first January 11 of January for 2021. As you can see, we downloaded almost 500,000 tweets, and actually almost 3,000 of them coming from some uncredible source. It means non-credible source. We cannot trust them. So we can create a retweet network with the node count and edge count for that day with our modules. Then we can create our networks. As you can see, for each day we are creating some retweet networks, mention networks, reply networks, and we can try to visualize them. You can see from here the same colors are some groups for that day, and it means that for that group they are trying to talk about the same thing. They are always retweeting themselves or mentioning about the same thing, and this is the graph of that. Okay, after everything is done, we are trying to do something like this. Okay. In the final stage, our misinformation detection module comes into play, utilizing data from the data labeling, centrality calculation, and community detection modules. And this module compares users who have posted tweets in the identified communities with those whose tweets were flagged as misinformation. Additionally, it identifies both accounts within each community and measures their significance. It means we at the end we have an output like this. The first column is showing it's a tweet network or mention network or something like this, and the second column is the centrality, which we are measuring. Actually, this output is measuring only the misinformation labeled tweets, and then we are trying to show that something like this. In the C column, we are showing that the network has 36 node in the community. I mean, this is a community, and we have 36 nodes. And in that community, the sixth one, the sixth most important, the sixth influenced one. Actually, we are trying to solve it, trying to order it with the degree centrality, and the sixth one and eighth one, the 31 and the 33 one is labeled as misinformation. And it means that in that community, there are four tweet which is labeled as misinformation, and it shows us in that community there could be a misinformation spread. It, as you can see in here, we have another one which is showing that betweenness measure, which is measured by betweenness centrality. It's also a retweet community. It also has 36 nodes, but in that community, the second important node is labeled as a misinformation. So in here, there could be a misinformation thing. And I'm jumping our conclusion and future work part. In conclusion, the proliferation of misinformation on social media platforms, especially during public health crises like the COVID-19 pandemic, has become a critical concern. And our research proposed a process that leverages social network analysis metrics to detect and analyze the dissemination of misinformation on social networks. Additionally, we provide a tool equipped with network science metrics and algorithms for social network analysis across various datasets. Through our prototype application, we have successfully demonstrated the effectiveness of our approach in analyzing the spread of misinformation using the Twitter case study. We actually maybe we believe that our proposed process and prototype application can contribute to the development of more efficient methods, and it could be measured by other data sets. We can use the other data sets for the future research. And other than that, uh, maybe we can, while our model currently utilizes the Girvan-Newman algorithm for community detection, we can use the other community detection methods such as Leuven, modularity-based communities, and tree partitioning, and we can measure the performance for the misinformation detection. And also as another future work, we plan to enhance the proposed architecture by incorporating functionality that allows user to import network's output and automatically visualize it in Gephi. And actually, in summary, our research offers a promising solution for combating misinformation on social media through the detection of analysis of its spread using social network analysis. And that's all from my side. Thank you for your attention. Currently, I am open to any questions you may have.
Thank you very much, Zafer. Any questions? Okay, thank you very much again.
Thank you.
Um, So I'd like to invite Yunsik Cheon.
Yes, give me a second. Let
Yes, yes.
me share my screen. Windows. Perhaps this one right here.
Perfect.
All right. Can you guys see my screen?
Yes, yes, we can see
All
it.
right. So do
Great.
you want me start
Yeah,
now?
yeah. So this is a blending functional program verification and assertions by Yunsik Cheon. So yes, you can start.
Okay. Hello. I am. Second. I am Yoon-Sik Chun, and I'm from the University of Texas at El Paso. And in this talk, I'm going to present our initial works on combining functional program verification and executable assertions. So this is outline of my talk. I'll start with motivation and tiny bit of background knowledge on functional program verification and the major challenge combining functional program verification and executable assertions and our approach to address these challenges and a few examples to illustrate our approach. So motivation. Assertion, as you know, is a Boolean expression that you insert in your source code. The idea when control reach the assertion, the condition has to be true. I do not. I have early background. I'm not sure how to change the background.
I'm sorry, we can see your slides.
Okay, that's fine. All right. Anyway, the assertion provides a quick and easy way to introduce runtime check. So this code snippet shows example assertions written in the Dart programming language. When you write the code, sometimes you make assumptions about your environment. For example, this drum method assumes that the parameter slot is in the certain range of values. And then you can express it about your assumption by documenting it, and also to check them at runtime by writing executable assertions. In addition to the assumptions, you can also document the code logics. For example, this method return result, and then you can state that return value should satisfy certain properties. So if you run this code with assertion enabled, if the assertion is violated, either assumption or code logic, you get the assertion violation error. So assertion provides a practical tool for debugging and testing. And our objective for this study is to combine executable assertions and formal proof as sort of complement techniques to reason about the correctness of code. In particular, we want to be able to use executable assertions to support and enhance functional program verification, because assertion is a lightweight approach and it's easy to use to incorporate runtime check. But downside, typically the assertions are partial. It doesn't completely describe the behavior code. On the other hand, formal verification, it's a heavyweight in the sense its use is a lot more involved than assertion, but it provides static, complete proof. So we want to combine these two approaches. So the particular formal verification technique that we consider is called functional program verification. So let me give brief background on functional program verification. In functional program verification, essentially you view program as a mathematical function that take one state and produce another state. We call state changing function or state transformer. And then you can document formally this state changing functions using a notation called concurrent assignment notation. So essentially this notation means that the final value of xi, which are state variable or program variables, are ei evaluated in the pre-state. And here is an example. You have 3 lines of code. If you read the code carefully, you will see that these 3 lines of code swap the value of x and y, and this is the function that is implemented by these 3 lines of code. The final value, post value of x, is the pre-value, initial value of y, and final value of y is the initial value of x. And here is the function that is implemented by these 3 lines of code. So there are some advantages of functional program verification, especially compared to while logic. The most important advantage is support forward reasoning, which match the way we informally reason about the code. On the other hand, if you look at the whole logic, it's sort of backward reasoning because you calculate precondition, because the precondition from the post-condition. You don't read code backward, right? So the one key advantage of functional program verification, it match informal reasoning by supporting forward reasoning. And also the mathematic that functional program verification is based on sets and functions, not first order parallel logic. So perhaps functional program verification could be more approachable by the average programmers. So how you do actually verification? Well, essentially you do 3 steps. The code you want to verify, you specify its behavior by writing the function that you intend to implement. We call it intended function. It shows your intention of your code. And then depending on how you write the code, you can actually calculate the function that is implemented or computed by the code. We call code function. So you have 2 mathematical functions. Verification essentially means that you compare these 2 functions to make sure that your code function conform to your intended function, your specification. And let me show you a small example to illustrate the functional program verification. Let's say you have this for 5 lines of code. To verify this 5 lines of code, you write intended function for each section of code. So at the top, this is the behavior whole code. As you can see, it calculates find a largest value in A and store to R. And then we have 2 sections, initialization and loop. For each section of the code, you also document intended functions, say F1 and F2 for while loops. In the loop body, we have F3. Now, once you document your intention for each section of code, now you can verify. Here are some of the proof that you have to do. At the top level, if you look at F0 is decomposed into F1 and F2, which means that you have to prove that F1 followed by F2 is correct implementation of F0. That's the first negation. But if you look at, it's essentially composing 2 mathematical functions, F1 and F2. You prove that this composed function is correct implementation of F0. And then for each section, F1 is correctly implemented, F2 is correctly implemented, you have to verify it. But the proof of this F2 is somewhat involved because you have loop, but essentially you do induction. So the F2 become induction hypothesis, and then you verify basis, induction steps, and so on. Okay, and here's example verification at the top level. But as you can see, essentially you manipulate mathematical functions. You compose 2 mathematical functions, and then you check domains, ranges, and so on. So average student who has some background in the sets and functions should be able to perform this formal proof. So what are the challenge of combining functional program verification with executable assertions? Well, the main challenge is there are 2 fundamentally different techniques. Even if both express code behavior and constrain the state transition of your code, but the way you state its behavior are fundamentally different. Assertion-based approach, typically you write a pair of assertion called pre and post condition. But if you look at each assertion, say P and Q, it's a Boolean expression written on a single state, either pre-state or post-state. And then you don't explicitly define this state transition, but you do implicitly by saying that pre-state has to satisfy P, and executing program should produce post-state that satisfies Q. Okay. On the other hand, if you look at the functional program verification approach or intended function, these formula are written in terms of 2 states. So EI is expected value, which should be evaluated in the pre-state. And XI is final value, which is the value that need to evaluate in the post-state. So the formula consists of 2 states, and sometimes the function is partial. The condition P is also evaluated in the pre-state. That's one difference. And another key difference, you explicitly define the state transformer as a mathematical function. And this table shows some difference between assertion-based approach and intended function-based approach. And yet another key difference, the way you formulate expression or formula are different. For example, in assertion, it's a Boolean expression on a single state. You constrain sort of relationships among the state variable, so it's algebraic style. On the other hand, if you look at the intended function, you actually calculate or construct expected value using pre-values, EI, and then you compare with final value. So it's more or less like a constructive. Instead of constraining the relationships, you construct expected values, and then you compare it with actual value. Okay, so how we address this difference? Well, we want to be able to execute intended function as a part of program execution. And our approach to translating intended function to executable assertion, we use two assertions. One will be executed in the pre-state, and the other will be executed in the post-state. And this shows the key idea of our translation. Here is intended function. Xi's value is EI, which is evaluated in the pre-state. So in the pre-state, we use sort of helper function, assertion-only function, assign, which essentially evaluate EI in the pre-state and store to a local variable that we introduce for the purpose of writing assertions. Okay, and then you execute code. Now you become post-state. In the post-state, we have another assertion inside the assert statement, and we use another assertion-only function, library function or helper function called ensure, which take actual value and calculate and store the expected value. The ensure compare these two. So that's the sort of key, but there's a lot of details. And we can make the translate code more readable. So one possible way we can provide a high-level vocabulary by explicitly representing and storing executable assertions, intended function that we call intention. In fact, we implemented a class intention to represent executable intended function as an object. So here is a simple use of intention. So you create intention, and then you call expect function in the pre-state, which essentially calculate expected values EIs and store them inside of the object locally, so that the user doesn't have to worry about management of the expected values, storing them, and so on. And then in the post-state, you call another method called ensure, which take actual values and compare actual values with the expected value that are stored by intention object. So comparing this and the previous, it's a lot more readable and more hopefully maintainable. Okay, another a bit of detail. Some of the intended function can be a partial, which means that your code work only some certain set of input. It's not a total function. So in concurrent assignment, we express this partial function, use this arrow notation. It's like similar to guarded expression. The idea when the condition P hold in the pre-state function. So to support this conditional concurrent assignment, we extend our vocabulary. For example, we introduce another assertion-only function called assume, which essentially calculate the condition P in the pre-state and store in yet another assertion-only local variable, and the assign, which calculate expected value, are evaluated only if this condition holds. And then in the ensures, we pass this P as optional parameter. The idea, you check the actual value comparing to expected value only if this P holds. And we can also extend our intention class that represent executable intended function. For example, expect you extend to take P condition and the expect evaluate EI only if P holds, where EI is passed as lambda expression. Okay, let me show you, I guess I have only a few minutes. Let me show you the examples how we can use this approach. The example that we pick, we implement the Connect4 app. I assume that everyone are familiar with this in Dart and Flutter. And here is the model. The grid is called board, which consists of a bunch of places. Each identify unique X and Y index, and each place is associated with 0 or 1 player. The idea, this player has a disk dropped on that place. And there are several operations, but one key operation is drop method, which take index of slot or column and place the player's disk on that column if there is empty place. And here's one possible implementation with typical assertions such as assumptions and partial sort of post condition. And essentially the logic, you check all the places in the column from the bottom to the top. When you find the first empty one, you place the player stone there, okay? And it returns the place. But the description of the assertions pre and post condition is sort of partial. We can make it complete. We can document the complete behavior of this code by writing intended function. Here is one possible formulation. So if you can see, it's conditional. If the condition, if slot is valid and slot is not full, then you return a place that you find by using this helper function called find place. Here's the definition. And then you set that place to player with a given argument. If the condition doesn't hold, return value should be null. Okay, and with this intended function, we can translate this intended function to executable code. And here is our translation that we followed our approach. So as we said, in the pre-state, we create intention, and then you call expect to calculate expected value, which we also store that internally. And in the calculation, we use the helper function called find place. We translate this helper function to a local function in Dart. In Dart, you can embed a function inside another function. And then you have your logic, and in the post state, you call initials to check actual value with expect value that are stored in the intention. Okay? And we think one good use of our approach to assist verification of loop. The reason verification loop is challenging, it involves inductions, and also you need to formulate a correct induction hypothesis. They say that the most difficult part is not the verification itself, but finding correct induction hypothesis. Perhaps we can formulate sort of candidate induction hypothesis or intended function for loops, and then you can translate this intended function to executable assertions, and you test your code by providing sample inputs. And if this intended function or induction hypothesis holds every iteration, you have better chance that this may be a correct induction hypothesis. Then you can proceed your formal proof. So in summary, we performed sort of preliminary works on combining functional program verification with assertions, and we translate intended function to executable code by essentially introducing a pair of assertions. But there are some interesting technical details. For example, something that we didn't consider, how you compare two values in all contexts, because there is different notion on comparison, object equality, value equality. Sometimes you need to clone the object for value equality. And some other future works, we want to evaluate the effectiveness of our approach by doing sort of case studies, and then we want to formulate the translation rules, and perhaps we can build the tools. And ultimately, we want to provide how we use the executable assertions in conjunction with formal proof done in functional program verification. Okay, that concludes my talk. Anyone has any questions?
Thank you, Yunshik. Thank you for also staying in time. Any questions? Okay.
In any case, if you have any questions, you can send the email. Thank you.
Thank you very much again. So we'll go on with the work on the use of graph embedding techniques for clustering user browsing navigational behaviors by Neil Tasgetir and Mehmet Akkas. So sorry for butchering the names.
No, I'm here.
Yeah. Okay. Sorry. Can you share your screen?
Okay.
Okay.
And can you see my screen?
Yes, I can see.
Oh, sorry.
Great.
Okay. With your permission, I can start the presentation.
Yes. Oh, sorry,
Okay.
something. Okay. You can start. Yes.
Okay. Thank you. The subject of the paper is about on the use of graph embedding techniques for clustering user navigational behaviors. The introduction is clickstream data is a user's activities on the web or mobile as represented by the sequence of links they click on. Also, clickstream data provides a window into the how users navigate a website. Weblog files are created from this clickstream data. documenting user behavior on the website. Web usage mining can be done on different types of files, including web server logs, application server logs, and application level logs. This study aims to fill this gap by proposing a method for classifying users using a clickstream sequence data. If you go through an e-commerce website, we can measure the behavior of a user by analyzing whether a user will buy a product by analyzing the click data. About classifying users using a clickstream sequence data, the word-to-vec and not-to-vec embedding algorithms were applied to define and model user behaviors using click data from an e-commerce site. A business process for classifying users who make a similar gestures on the clickstream dataset was proposed, and a prototype for this purpose was implemented. The research in this paper aims to address the problem of how to design a business process for classifying users in e-commerce website, e-commerce industry using embedding methods and unsupervised machine learning algorithms. In order to achieve this, the following research questions were explored. One of these problems is what's the optimal business process architecture for defining, understanding, analyzing, and classifying user navigational behaviors. This question seeks to identify the best way to analyze the user behavior and develop a process that can effectively cluster users based on their behavior. Second problems is how can a single vector represent each session to analyze the data of a session-based web browsing graph? This question seeks to determine the most effective method for representing user behavior as a vector that can be analyzed and compared to other user behaviors. The last problem is how can graph-based data definition approaches be used to evaluate the success of a business process for the clustering goal of providing data meaning. This question seeks to understand how the use of graph-based approaches can aid in evaluating the effectiveness of the business process for clustering user behavior. By exploring these research questions, this study aims to develop a business process software architecture that effectively clusters users based on their navigational behavior in e-commerce websites. You can see the proposed business process is shown in this figure. This workflow comprises several key modules, including a data processing module, group by session ID module, embedding module, session-based calculation of vector data module, clustering module, and clustering result evaluator module, and visualizing module. First, we process the raw data, and as a result, we get data version 2. Then we get data version 3 by grouping based on session ID. Then we try embedding methods in data version 3. Then we measure the success of the embedding methods. After the embedding method is applied, clustering methods are applied. We measure success with SLED score to evaluate the results. Finally, we visualize these results. In the data processing module, the initial step in the proposed business process is the data pre-processing module. The first task is to make the URLs more readable. We apply the regex operations to each URL, resulting in transformation shown in this figure. By applying these regex operations, we have obtained a single label from each URL. For example, if we look at the first URL, which label is added at the end of the URL, this is the label. We can read in this label in the this URL. In this way, we have expressed what action the user is doing with a single label. Once these labels are added to the data frame, a new data frame is created to represent data version 2. In the group by session ID module, the weblog file contains all session information data for a user. When a user logs in to the website, they perform a series of clicks, each of which is recorded in the weblog file. If the user logs out of the website, the session ends and a new session begins when they log back in. Each session is identified by a session ID in the weblog file. Once the label corresponding to each URL is identified, unnecessary columns are dropped, and the final data before grouping by session ID is displayed in the first table. To achieve the second table, first we clickstream data was sorted according to the time parameter to obtain the pages in the pages visited in the correct order. Next, the data was grouped by session ID and the corresponding labels were aggregated using commas. In the embedding module, each session in the dataset has a unique sequence value, and each label in the sequence requires a vector for the clustering algorithm. A novel methodology was developed using vector-based data representation techniques such as word2vec and not2vec to create appropriate embedding vectors for the patterns in the dataset. Two different embedding approaches, namely word2vec and not2vec, were utilized to create vectors for each label in the vector creation process. To create vectors, each label in the sequences need to be obtained. Created a corpus to achieve this. In this function, these sequences were split using commas, and each word was added a corpus list. This list was then fed to the word2vec algorithm. Vector creation for not2vec. The not2vec algorithm differs from word2vec in that it is graph-based. To implement the not2vec algorithm, a graph must be provided as input. Like the word2vec algorithm, not2vec produces vectors as an output. Sequences in each session expressed as a graph one by one. The algorithm creates a weight with the frequency of consecutive labels. Then this graph is given as input to the not2vec, and a vector is obtained for each session. In this clustering module, two distinct clustering algorithms were employed. The first of these was the k-means algorithm, which falls under the category of assignment-based clustering methods. The second algorithm was the dbScan, which belongs to the density-based clustering method. Our clustering module is designed to be extensible, so enabling us to incorporate additional clustering algorithms easily. Both algorithms have their strengths and weakness and can be used depending on the problem at hand. For example, k-means is simple and fast, but it assumes that clusters are spherical and equally sized. dbScan, on the other hand, can handle clusters of different shapes and sizes. sizes, but it requires setting the minimum density and radius parameters appropriately. K-means algorithm is an assignment-based clustering algorithm. The algorithm starts by randomly selecting k centroids, where k is the number of clusters that are intended to be created. Then the algorithm iteratively assigns each data point to the nearest centroid and updates the centroid location by taking the mean of all data points assigned to the centroid. This process is repeated until the centroids no longer move or a maximum number of iterations is reached. DB-scan is a density-based clustering algorithm. The algorithm groups together data points that are close to each other in terms of distance and density, and separates points that are in low density regions. The algorithm starts by randomly selecting a data point and checking whether it has at least a minimum number of neighbors within a specified radius. If there are enough neighbors, the algorithm creates a cluster around the initial data point. Then it continues to add new points to the cluster as long as they meet the density and distance requirements. Sorry. When there are no more points that meet the requirements, so the algorithm selects a new unvisited data point and repeats the process until all data points are visited. In the clustering result evaluator module, the performance of clustering algorithms was evaluated. One commonly used metric to measure of effectiveness of a clustering method is the Slide coefficient, which is also referred to as a Slide score. The performance of the clustering algorithms was assessed using the Slide coefficient score. In the Slide coefficient or Slide score is a metric used to calculate the goodness of a clustering technique. Its value ranges from -1 to 1. One means clusters are well apart from each other and clearly distinguished. 0 means clusters are indifferent. -1 means clusters are assigned in the wrong way. In the visualizations module is responsible for visualizing the results of the clustering algorithms. In the implementation evaluation, the implementation of the proposed workflow involved using the GenSim library for the word-to-vec embedding method. While specialized libraries are available for node-to-vec algorithm, the necessary steps for the algorithm were chosen to be developed by ourselves. As node-to-vec is a weighted graph-based algorithm, the weight of each edge was computed as shown in the weight column on the table after converting all sequences into data tables. The stellar graph library was utilized to generate graphs, and the biased random walk algorithm developed for the library was used to create random walks in the graph. This algorithm takes graphs as input and generates a list of random walks as output. After random walks were generated, the skip-gram algorithm was applied to obtain the vectorized version of each label as output. To create a single vector for each session, the weight of each label in a single sequence was first determined. Then each label's vector was multiplied by this weight to obtain a vector for each label. Finally, each label vector has aggregated and divided by the number of labels in a session. This results in a single vector representation for each session, which was used as input for both word-to-vec and not-to-vec algorithms. In the evaluation, in the clustering phase is
just a heads up, Neil. It's 15 minutes now. Okay, so are you close?
okay. Mm-hmm.
Yeah, keep going. I'm just a heads up. Okay.
Okay. The k-value for the k-means algorithm was determined using the elbow method, while the number of clusters for the dbScan algorithm was determined automatically by the algorithm based on the proximity of the labels to each other. The resulting number of clusters is presented in this table. The silhouette scores obtained for the k-means and dbScan clustering algorithms for each embedding method are presented in this figure. The bar charts with blue color indicates the clustering results when word-to-vec. The bar charts with orange color indicates the clustering result when not-to-vec. Our test results indicate that graph-based embedding approaches lead to more successful clustering results. After the word-to-vec and not-to-vec embedding algorithms were applied to the entire dataset, the k-means and dbScan clustering algorithms were applied to perform clustering. This figure shows that clustering visualization of word-to-vec and not-to-vec with k-means. This figure shows that clustering visualization of not-to-vec and word-to-vec with dbScan algorithm. Then conclusion and future work, our test results indicate that graph-based embedding approaches lead to more successful clustering results. In the future, we plan on incorporating supervised machine learning methods alongside unsupervised machine learning in the proposed workflow to investigate users' behaviors. We argue that this will allow us to not only cluster users based on their browsing behavior, but also predict their next best action. Thank you for attention. If you have a question, I'm open to questions. Thank you for listening.
Thank you very much, Neil. Any questions? Okay. I'd like to thank our speaker again.
Thank you.
And I invite Johan to share their screen. Thank you. So
yeah, I'm sharing now. Can you guys see the screen?
Yeah, we can see it. So the next topic is innovation helixes, blockchain, open innovation, and phased rewards in prompting circular design in waste management, a conceptual HCI study. So you can start.
Yeah. All right. So yeah, I just realized we're not using the template provided by the conference, but I think nice change of pace since the design's a bit different. But we are actually reusing some of the design from previous presentations, since this study itself is actually a assignment based on the course human-computer interaction from Summer University. So yeah, I'll just start with my introduction just to clarify that one. So hi, so I'm Johan. I'm part of this study, which is called Innovation Helixes, Blockchain of Innovation and Phase Reports in Implementing Circular Design and Waste Management. It's a conceptual human-computer interaction study. In fact, the lead author of this study is actually my professor, Professor Lee. He's actually in the room now, I think. Hi, Professor Lee. And so this one, this study itself focuses on it's an assignment based on given to students, which you can see right now. The list of the authors is quite long because it's a group of students actually did this study. In fact, we did that and submitted, so it's part of that. And for the assignment itself, this is based on the course of human-computer interaction. So this is mainly regarding this idea, the ideology behind that. So I'll move on to the introduction. Okay, let's see. All right, so just to give a brief introduction regarding what the study is about. This study focuses on the 12 sustainable development goals. So that goal itself actually emphasizes on sustainable consumption, production, and circular economy. So for circular economy, what it does is it stages a unique design phase for developing new products and optimizing materials. Right now, a lot of the basically around the world, we follow a linear fashion in terms of the economy where we create and then we use and dispose. So circular economy kind of wants to solve that issue because we are creating too many waste because of using that linear economy model. So it does that by developing products with sustainable, sustainable ideas in mind. So we can having a circle, we're getting the cycle of the product, so we can reuse the waste and just kind of we can eliminate waste issues.
I'm sorry.
So yeah,
I'm sorry to interrupt you. I think sometimes when you move back, the microphone doesn't catch your voice so well. So
okay, all right.
I
Try
can
to
hear you.
speak
I can hear you very well now, but when you lean back, sometimes
Okay.
almost
All
no.
right, all right. Yeah, no worries. Then I'll just sit still. Okay. All right. So yeah, moving to the third point is that circular and sustainable designs actually share similar concerns, but they kind of differ in different kinds of focus. So one focus on more on value preservation and one focus on resource optimization. But we look through two of these sort of these concerns, but we're trying to figure out something that comes in between these two concerns. And circular economy, even though it's a great idea, it actually has a lot of challenges in various countries. Malaysia, for example, which is the university that I'm from, and this, we have quite a few challenges regarding trying to implement a circular economy design. So it's a little bit hard to try to get people to, and even corporate, because it doesn't really align with the way that we develop products right now in terms of the trends. But successful implementations of this has been seen in places like Vietnam or Italy. Yeah. So for the problems that we identified within our study is that agencies like the EPA or the World Bank actually encourage a hierarchy for waste management. So we look through a series of waste management techniques and something that follows through a flow where a lot of the reduction, reuse, and recycling is done through several stages so we can incorporate less waste. So developing countries actually face a lot of challenges in trying to implement circular economy, as mentioned before. So because something like this rarely has any incentives for people to do it. This is not really a profitable thing, and there's also a lot of political will and comprehensive policies involved trying to get this circular economy going. So that's one thing that a lot of countries are facing, the challenge of trying to implement circular economy. For Malaysia, we try to implement circular economy, and several good examples that has gone through. One of it is actually recycling ocean bounded plastics, trying to make it up into reusable products. Some of the companies actually done that. Prime examples like Adidas with their shoes or Nikes with their clothing line and stuff like that. And one of the other company actually implemented a recycling system, a waste separation and recycling system solution where it actually rewards users based on their recycling activities and stuff, which this idea actually inspired our solution. So for our study, we aim to kind of explore how we can expand circular economy beyond just waste management to the public itself, and we consider the triple or quadruple innovation helixes so we can have a broader and more open participation. So for the objectives of the study, we focused on circular economy, right, in the context of open innovation / feedback loops towards concepts of such as metaverse, and we want to simulate one of the pre-existing ideas called Idea Storm by Starbucks and also by Dell as well. It's an open feedback kind of system where people take in ideas. And the main challenge of leveraging this metaverse elements is we try to enhance the ecosystem interconnections, user experience, and sustainability. So there's a long list of objectives here. It's very assignment based when you look at it, but I'll go through the few points. Firstly, we reviewed a lot of the literature regarding waste management and circular economy itself. So we want to make sure that we have done through a comprehensive review of any pre-existing studies and previous work by people. And we want to identify some possible strategies. Hopefully, we can find something that not much has been done yet or has been investigated yet we can do something new. And after that, we follow through. We do a SWOT analysis, so we can make sure that the solution that we came up with is feasible. And the SWOT analysis that we have done is mostly focused on Malaysia itself, because we want to make sure that this solution is feasible around our area and in our environment, since we invest in our environment. And after that, we look through to assess the feasibility via mind map. So we look through several aspects just to extend on the SWOT analysis itself. So we look through several aspects such as individual, community, economy, environmental, and technological concerns, which all of these aspects actually come from the sustainability awareness framework. And following that, we look through all the concerns, but with those aspects that we have look through, and then we try to prioritize on each aspect so we can design the system with the priorities in mind. And following that, we design a Figma prototype based on the review literature and a lot of the non-functional requirements that we came up with, so that this Figma prototype is sort of designed out. And we'll send that Figma prototype to various respondents so we can make sure that we can get two different testing stages, such as alpha testing and beta testing, so we can further refine our Figma prototype. And after that, we make the Figma prototype. All right, so before I jump into the methodology of our study, just a few things regarding the circular economy framework, because I keep mentioning circular economy. We look through circular economy as a framework itself with 66 different points. The first three would be design. Since circular economy enhances or recommends in terms of a design that is reusable in a sense, so everything starts all the way back to design, and it tries to optimize in terms of material use and minimizes waste, and it involves a system thinking mindset and requires resource optimization to create new different business opportunities. After that, it looks through the production remanufacturing, so it tries to preserve more material value when doing remanufacturing, which reduces resource demand and carbon footprint. Along with that, the distribution of circular economy just educates consumers about the product life cycle, because usually we're used to buy something, use something, throw away something, but the distribution within the circular economy framework is a bit different. It includes trading, repair, and taking services. And following that, we have the consumption aspect, which consumers are encouraged to use their products as long as possible, so we can extend the lifespan of the products. And they all are educated with policies such as products are able to be repaired instead of being thrown away. And finally, moving on to collection and recycling. Once the product has finally reached its lifespan, definitely we have to throw it somewhere, and we have efficient waste collection method that we can collect all the waste in one go, and moving on to recycling, where these products will then be recycled, and non-recyclable ones will still be waste, but effectively we want to exclude those residual waste from the circular economy. So moving on to the methodology of our study. As mentioned before, this study is based on the coarse human-computer interaction. So a lot of our conceptual models actually grounded within the contextual inquiry of human-computer interaction. The first four questions that we'll be asking regarding when we're designing our solution will be: what will the users be doing when they're carrying out their tasks? And how will the system support these? What kind of interface metaphors, if any, will be appropriate? And what kind of interaction modes and styles to use? And at the same time, we also incorporate a value-centered design, which is an approach in design thinking. VSD, or value-centered design, incorporates iterative, conceptual, empirical, and technical investigations reflecting key values like human value, welfare, autonomy, and accountability, and environmental sustainability. Surprisingly, VSD actually aligns quite well with Sustainable Development Goal 12, and incorporating the metaverse elements, we found that there's potential for significant business expansion and enhanced quality of life through the 2 points incorporated. And for the proposed system, we actually will go through several evaluations from the human-computer interaction approaches, such as the heuristic evaluation, computer system usability questionnaire, and the user experience questionnaire, so we can cross-verify our results and we can provide a comprehensive understanding of user perception. So moving on finally to our proposed solution. Several questions, several answers have been given for the questions that I mentioned previously, which the interface metaphors in the system are contracts and bids, open innovation, and open feedback, which right now doesn't make any sense, but I'll move on so we can get better idea of that. And the second point that we have come up with in terms of our proposed solution is idea generation. And the idea generation part basically looks through the 6 points of the circular economy framework that I mentioned previously, where we want get generative ideas based on the economy framework stages and regarding like design, production, remanufacturing, distribution, consumption, reuse, repair, collection, and recycling. And for each of the ideas, constructive feedback is encouraged and it will be rewarded if the feedback is provided. So then there's also the idea selection factor, where in terms of the solution itself, which is kind of like a website where people submit ideas and bid through ideas and stuff. The users can view and submit bids on ideas listed on the website, and the user can also propose of what they want to do with the ideas and what kind of possible impacts that will come with the ideas. And we'll evaluate based on the sustainability frameworks, individual, societal, technological, economic, and environmental impacts. And once the idea is up and it will be open up for submission, the idea is actually treated as a smart contract, which correlates to the point of the blockchain mentioned. So it's kind of using that kind of theory until the outcome is no. So we have a set of judges that will, evaluate the ideas using the sustainability framework as well. So once that is done, the smart contracts will actually be submitted to the database, and then each successes of each stages in terms of that idea will then be rewarded as well. Which those stages are also the circular economy framework stages. So once we've come up with this solution, it's not up there yet. Well, we've done a SWOT analysis to sort of analyze on how feasible it is to develop a waste management system in Malaysia, which is our country. So look through some of the strengths, weaknesses, upon opportunities and threats. And the strengths would be that the market is actually aware about the circular design economy trend, which then this will potentially open up and develop new opportunities for different kinds of stakeholders. But for the weaknesses, then there's quite a lack of awareness of how do we use materials. Recycling and stuff isn't big in Malaysia, but also in companies as well. A lot of them just treat waste as a single one way to go and stuff. Doing more things to try and separate waste and stuff. So companies need to be encouraged on circular design in terms of the manufacturing itself as well. And we don't really have an ecosystem that does better extraction and recycling manufacturing. And yeah, we're gonna have 2 more minutes left, but yeah, I'll move on to opportunities. So there's also possible green solution companies where companies can actually based on their ideas on green solutions. And finally, with threats, we have looked through there's not so many developed practice, and there's a lot of reviews and open participation that's required in terms of the review. And yeah, there's also the undercutting of competitors where there's a lot of illegal waste management done in Malaysia as well. So here's the mind map. I think I'll skip through that because yeah, these are just several aspects that we have looked through in terms of the evaluation of different aspects in terms of the sustainability framework. And yeah, so just showcasing the prototype here. It doesn't look so good because we try to shrink it down so it fits the presentation slide. As you can see, it's just a website quickly to get people to submit their ideas regarding waste management. So this is trying, these are the pages that we're trying to sell them the idea about. And moving on, showcasing the alpha testing results. Just going through that real quickly. We have done the UEQ, CSUQ, and HE, which is the questionnaires of the HCI approach, where we have found that the website is perceived to be quite good in terms of the usability, and it's one of the primary highlights of the questionnaires. But definitely there's still improvements to be done, which in our beta testing phase, we actually refine some of the pages, which we refined the reward landing page, which is the page that you see before, and we added a leaderboard and feedback landing pages, user feedback feature pages, and an AR functionality to video to measuring prototype. Right now, saying that doesn't make a lot of sense, but you can refer to a study that all the screenshots will be there in terms of all the pages that I mentioned. And finally, move on to beta testing. We did another round of testing after adding our improvements, and we have showcased quite a good uptrend in terms of the results we see. And primarily, all the findings actually suggest that ease of use, clarity of information, and organization is key factors of perceived usefulness. And one of the things that we have found also is that error prevention, the aspect of error prevention actually helped in terms of like the overall results, where it forms the starting point of transformation. Definitely, then it will actually improve the acceptance of the technology itself. So people kind of know even if they did something wrong, there's ways to nudge them back. So there's this extended functional requirements that we actually look through and actually emulate from the Starbucks ideas form idea itself. So these are some of the aspects they've done. So just add on to showcase on that. So just to conclude the study, just to reiterate a few points, our study is based on the value-centered design model, the VSD, to leverage circular design principles and diverse perspectives in promoting circular economy. It recommends different stakeholders to use metaverse elements like AR and blockchain to improve waste management understanding and contribution. We use different questionnaires from the human-computer interaction principles, such as heuristic evaluation, computer system usability, user experience questionnaires to gain comprehensive insights into system development to identify areas for improvements, and the one highlight the importance of empathy in design thinking and expansion of AI and advanced technologies. So that's all from me. We'll just open up for questions.
Thank you very much, you. Any questions? Okay, thank you again very much. So the next work is artificial intelligence applied to digital marketing. But is there a speaker here by Teresa Gard and Samuel Bustos? Okay. So I don't think a speaker for this work is still here. I'm gonna keep the room open. I'm gonna share the pause page and yeah, hopefully the speaker will turn up. But
Panagiotis, do we need to wait or can we leave?
okay, I think the official time of the session is over because we started a bit late. So I think we can end the session since speaker doesn't seem to be here. So I'd like to thank you all very much.
Thank you so much.
Very interesting
Thank
session.
you. Have a wonderful
Thank you very much.
day or night. Bye.
Good evening.
Bye-bye.
Good
See you.
whatever. Bye bye.
Thank you very much. Bye.
Bye. Thank you so much.
Hello? Can you hear me?
I can hear you.
Perfect. How are you?
Fine, fine.
Great. I see you are this session's chair, right?
Yeah, I'm gonna chair the session.
Great, good.
Yeah.
Hello, everyone.
Hello.
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 Should we get started?
Yeah, definitely.
So I give the room to you, Vadim.
Thanks. Good afternoon, good evening, or whatever, everybody. We were starting our second session of the workshop devoted to computational pore mechanics and computational aspects of porous materials. And the first speaker in our session now is Denis Bratchikov, and he's gonna give us a talk about using machine learning to full waveform inversion. For full waveform inversion. Denis, can you hear us?
Yes.
Great. So you may start.
Okay. Oh, mm, mm, can you see my presentation?
Yeah.
Okay, I start. Good afternoon, everyone, and welcome to my presentation.
I'm sorry, Dennis. Can you put it full screen?
Okay. Wait.
Perfect.
Good afternoon, everyone, and welcome to my presentation. I'm here today to present a novel learning-based approach to seismic monitoring of hydrocarbon deposits for viscoelastic medium. My talk is particularly relevant for those who apply neural networks in geophysics exploration. My presentation is structured as follows. First of all, I would like to give an overview of relevance and methods of seismic inverse problem. Secondly, I'm going to consider a mathematical model of the propagation of seismic wave in viscoelastic medium. Next, I'm going to concentrate on the solution inverse problem with deep learning approach, mainly focus on the architecture neural network, creating synthetic training dataset, and the inference neural network. Finally, I'm going to discuss the approach for accelerating the generation of datasets based on Born approximation and transfer learning. Let's start with relevance of the problem. Reconstruction of reliable model of the Earth is prerequisite for the search oil and gas deposit in geophysics exploration. Seismic processing is a primary tool in seismic exploration to obtain a high-resolution subsource of geological parameters. One of the essential recoverable parameters in the study of hydrocarbon reservoir is velocity propagation of seismic waves and attenuation of seismic wave energy, since it characterizes the rock's fluid saturation. Thus, the knowledge of the spatial distribution of velocity and attenuation increases the reliability of interpreting the results of seismic observation. Seismic processing method mainly consists of stacking velocity analysis, migration velocity analysis, tomography, full waveform inversion, etc. Full waveform inversion has become a promising method for estimating the geological parameters of complex structure. However, FEI has several significant disadvantages. Some of them presented on the slide, but for us, main of them that FEI has a high computational cost. Thus, an efficient and robust technique is needed for optimal oil field development. What do we propose to solve this problem? Firstly, we will find exponential growth if we look at the plot of the amount of geophysical data over the past 30 years. Moreover, neural networks had remarkable achievements in computer vision and for solving inverse problem. Motivated by these advantages, we propose a novel approach for estimating velocity and attenuation based on deep learning techniques. The learning-based strategy saves computational resources on expensive seismic data processing by avoiding forward problem modeling. The proposed approach uses computational resources to generate a representative training dataset and train the neural network. At all subsequent stages of oil field development, processing seismic data is replaced by a trained neural network that predicts the petrophysical parameters of a reservoir from seismic data. By leveraging the power of deep learning techniques, our approach demonstrates significant potential for tackling this challenging problem. Now let's try to formulate our problem with math terms. The mathematical problem of restoring the parameters of a viscoelastic medium should be based on the theory of seismic wave propagation in media with absorption. We introduce the absorption of seismic energy using the quality factor, with inversely proportional to the ratio of the change in energy to the energy itself. Then, the propagation of seismic waves for viscoelastic medium is described by following system of equation in frequency domain. The first equation is responsible for the motion of continuous medium, expressing the law of conservation of momentum. The second equation establishes a linear relationship between the straight tensor and displacement velocity. The third equation is Hooke's law for isotropic medium, expressing the relationship between components of stress tensor and the strain tensor. The absorbing boundary condition of PML type are used as the boundary conditions. These slides demonstrate the quality factor we introduce express the absorption of seismic wave energy. We performed a series of numerical experiments with Q-factor variation in the target area at 160 to 210 meters depth. Calculations were executed for three groups of Q-factor values: elastic medium, 20, and 10. Seismic traces were obtained by numerical solving the system on the previous slide and taking the direct Fourier transform. The first bars on the graph correspond to the first arrival of P wave and the second, respectively, of a S wave. As can be seen, the variability of quality factor manifests itself in the dynamics of the wave field, since the wave amplitude decay with decreasing quality factor. Next, we can introduce forward operator F for our problem acting from model space to data space, where model is a vector from density, velocity of P and S wave, and quality factor of P and S wave. And data is a wave field recorded in receivers for many sources. Then we can formulate our system of equation on the previous slide as the equality data and the action of operator of the direct problem on our model. Then our goal is to approximate the inverse problem operator to obtain a model from input seismic data. We focus on approximating the inverse problem operator using a deep convolutional neural network. According to the universal approximation theorem, a convolutional neural network with a predetermined accuracy can approximate any continuous mapping. Therefore, if the dataset is representative, then seismic data mapping into the model can be learned with high accuracy. Next, I would like to discuss the architecture neural network we use for approximating inverse problem operators in more detail. This research proposed a neural network called ResUNet. This slide shows a block diagram of neural network architecture. It consists of unit frame, building from the convolutional block, and residual unit. In this architecture, high-resolution features obtained by the encoder from input seismic data combine with decoder output and transform in the model. Each convolutional block contains convolutional layers, batch normalization for regularization learning process, and function activation ReLU for establishing nonlinear mapping between seismogram and model. The residual and skip connection are introduced to tackle the degradation problem due to vanishing gradients. Now we concentrate on data that we use for training neural network. We use the synthetic dataset in this study. we choose the Gullfax field in the North Sea to create a training sample. The elastic model of this area field is shown on the slide. Assuming a viscoelastic model of our medium, we introduce a constant quality factor of P and S wave with value of 1000, indicating that both waves have almost no absorption. According to the information in research about Gullfax, we added a reservoir in a target area containing wells that confirm the presence of oil. We filled this area with a value of 1500 meters per second for P wave velocity and 10 for Q factor of P waves, indicating the presence of fluid in this area. Thus, we create the start viscoelastic reservoir model. Further, we assume that only model of P velocity and Q factor waves change. Next, we assume that the shape of the reservoir changes randomly after the injection of displacing agent. To achieve this, we vary the shape of reservoir using a stochastic algorithm. This way, we generate 1000 true models whose change we aim to restore. Some of them showed on the slide. Then we combine the change model for velocity and Q factor of P waves into a common tensor, which serves as a neural network's output. After generating models, seismic data is generating using a fourth-order finite difference game for numerical solution system of viscoelastic equation. The solver is parallelized by frequencies using MPI technology to accelerate the calculation time for creating a training dataset. Only the vertical component of velocity displacement is used to register a seismic signal. The data acquisition scheme is shown on the slide. Seismic data is first modeled for specific frequency for the start and true model. Then the real and imaginary parts are extracted from them. The corresponding data change is obtained by subtracting the data for the starting model from the data for the true model. The data change combined overall frequencies into common tensor, which serves as a neural network input. This slide demonstrates the neural network process. As a loss function, we choose mean squared error loss. As a score function, we choose R-square metric. The plot shows the change in this function in the learning process. The prediction accuracy on the validation dataset was 89% by the end of training. After training, the neural network was applied to the test dataset. The results of prediction change in the model of velocity and quality factor of P waves are shown on the slide. As one can see, the convolutional neural network is generally accurate in restoring the model from input seismic data. In the final part of the work, we propose a method to accelerate the generation of training dataset. Let's first focus on how we calculate the change in seismic data in the classic approach. First, we calculate the data for the starting model. Then, we calculate the data for the true model. Data change is obtained by subtraction. Thus, for each true model, it's necessary to solve the direct problem 1000 times. Therefore, it's advisable to calculate the change in data immediately, avoiding the calculation of full seismic wave fields. Because in our numerical experiments, it's assumed that the model of geological medium change locally around the reservoir, we can use the board approximation. The advantages of this approach are that it is enough for us to do a loop decomposition for system once for the start model instead of 1000 times for each true model. After creating a training dataset using the board approximation, similar to the slides above, we train the ResUnet neural network on this dataset. However, testing is executed on the test data obtained in classical approach since receivers on the surface recorded such data. The prediction results are shown on the slide. it can be seen that quality of predicting the change in the model by neural network has fallen since the value of R square metric have decreased by about 10%. In addition, some artifacts appeared in the prediction of the model. Nevertheless, we still correctly predict the spatial localization of the model change, its approximate shape, and absolute values. At the same time, the generation of training dataset was accelerated several times without a strong loss in prediction quality. In conclusion, I want to say that we approximate operator on inverse seismic problem to restore the depth distribution of velocity and co-factor of p-waves in viscoelastic medium using a deep convolutional neural network on realistic data from Gullfaks field. Also, we propose an approach to accelerating the creation of training dataset based on the Born approximation. Thank you for your attention. I'm glad to answer on your question. That's all.
Okay, thank you for your presentation. Is there any questions? If not, I've got a question. Using your neural network, you try to restore the shape of the reservoir where something has changed, right?
Yes, yes.
But you fixed the contrast. You fixed the changes in the velocity and changes in the quality factor, and just allows only the shape of the reservoir to be the subject of the search. What would happen if you also let the contrast to be variable? I mean, to be at least to be lower than what you presented.
Okay. You mean if data set were different, what would be?
Not the data set, but the model. I mean, you in your model, you changed only the shape of the reservoir.
Yes.
But how sensitive would be the algorithm if you also change the values of the velocity and the quality factor?
I think our prediction won't be accurate because results of neural network depend on representative data set, and we should edit such model with different values, velocity, to predict them accurate.
But is it? I mean, well, should you do training for all possible values of velocity and quality factor, or you can somehow optimize the number of things, minimize them? Do you have any ideas on that?
No, I have ideas to normalize value of model to interval of 0 to 1. I think that's all.
Okay. Well, yeah. Well, thanks a lot. Is there any other questions? Well, in this case, let's thank the speaker, and we may probably Elmas may proceed to the next presentation. And the problem here is that the next two presentations are gonna be given by me, so I have got to ask Evgeny Rominsky to chair this part of the session.
Okay, this is not a problem for me. Okay, the second speaker now, Vadim, our former chair. Please, Vadim.
Okay. Okay, can you see the presentation?
Yes, we see full screen. That's okay.
Good afternoon, everybody, once again. And this talk is the third talk in a row on what we are doing with numerical dispersion mitigation neural network to speed up seismic modeling. And I've got to confess that this like abstract and the presentation were prepared like half a year ago, and it was the first attempt to understand how can we combine different measures in the seismogram space, in the model space, and so on to minimize the number of seismograms in a training dataset. And quite a nice talk was given by Elena Gandul just a few, like 2 hours ago, and her talk was on the cutting edge of what we are doing right now. And this talk is like a preliminary, should be considered as a first step toward those results. So just like a small preliminary results to what already been done. Okay. Once again, and Kirill told about NDMNet already in quite nice details and showing just the same pictures. So let me just briefly remind you that the NDMNet is designed to speed up seismic modeling. If we are doing seismic modeling using conventional methods like finite difference, finite elements, or whatsoever, we've got to reduce the grid size to get more accurate results. And if we decrease the grid step, we increase the size of the discretized problem. And if we're talking about 3D statement, if we just reduce the grid step by the factor of 2, we increase the size of the discretized problem by the factor of 16, which is not that nice thing to do. But however, if we do not care about it, we would finish up with quite an inaccurate results. And you can see the example here, the fine grid results on the left, coarse grid results in the middle. They look pretty similar, but if we compute the difference in the same scale, the difference is presented in the same scale, we can see the numerical error, which is mostly represented as a numerical dispersion. So we've got the phase wave phase shifted, which is not that good thing for the seismic processing procedures. So what can we do to try to improve the situation? The idea is the following: we want to be able to compute the seismograms using coarse enough mesh and do it fast, but maybe not that accurate. On the other hand, standard acquisition system, which is supposed to be simulated, contains thousands and dozens of thousands of shots. I mean that we need to solve a huge number of similar problems with different right-hand sides. And the idea is to use compute a small number, is to simulate a small number of such problems using fine mesh to construct the training dataset. And after that, train the neural network to map coarse mesh data to fine mesh data for these particular source positions, and then apply this neural network to all other positions. So the idea was already described by two previous speakers, I mean Kirill and Elena. And the main thing here, the main the most time-consuming step here is to pre-compute the training dataset, because we need to use fine grid to do it. And of course, if we can minimize the number of shots and minimize the number of problems to be solved using fine mesh, we can improve the overall performance of the algorithm. And okay, so here's an example of how it works very pretty nicely, and so on and so forth. All this was presented by Kirill already, and some speed up estimation for a 2D problem. And okay, and the idea was, and the idea which was used to construct the training data set in the previous examples is to use the equidistantly distributed sources. So in this particular example, we had 1900 sources in the entire data set, and then we used just 10% of them to generate the training data set, and then finally we finish up with a speed up of the algorithm by the factor of 4. And of course, if we reduce the number of sources to simulate the training data set, we expect the better performance and then higher speed up. And to do so, first of all, we consider the another metrics to construct the data set. So if we're talking about equidistantly distributed sources, as we did before, it means that we preserve the distance between the training data, like Hausdorff distance between the training data set and the entire data set. But in terms of the distance, the Hausdorff distance between the sets was based on the physical distance between the source positions in two data sets. So we introduce the distance between the source positions, then we can using these metrics we can introduce the Hausdorff metrics between the two sets. So that's how it was done previously. After that, we decided to take a look at the seismograms themselves. I mean, the seismogram can be considered as an object, and we can introduce and we can consider the linear space of the seismograms, introduce the metrics in there, and these metrics can be like L2 based on L2 norm or normalized root mean square, which is pretty much the same thing between the seismograms. And then once we introduce these metrics, which knows nothing about the source position, but it based directly on the properties of the seismogram, properties of the objects we try to deal with, we can construct the training data set which like preserves or which minimizes the Hausdorff distance between the seismograms in the in these metrics, just directly measured between the seismograms. And we did it, and then we compared the results. So for this particular model, if we use the equidistantly distributed sources, we okay, this is a speed up and stuff. We use different data sets as a training data set. Applied the algorithm, measured the normalized root mean square error between the true data computed on the fine mesh and the predicted data, and then you see that the more data we use in the training data set, the better the prediction is, and the speed up is provided over here and on all things like this, and it's not that impressive. What would happen if we use the training data set based on NRMS metrics between the seismograms? We see that the distance between the these plots they represent the distance between the between each seismogram to the training data set. And these three cases correspond to different limiting NRMS Hausdorff distance between the training data set and the entire data set. So in the first case, it doesn't exceed 60% and 80 and 100%. So the higher error the higher distance in the NRMS metrics we allow, the less sources we need to use. And in this case, we also computed several data sets, performed NDMnet training, and then applied it, and measured the error which we've got after all. And you see that in this case, the number of sources is much smaller than in case of equidistantly distributed sources, to get pretty like relatively similar results. So okay, the same thing was done for the other model, which is called BP model. I will skip the detailed discussion, but provide the two tables over here. So again, we use the training that data set based on the equidistantly distributed sources, and the based on the NRMS distance between the matrices, between the seismograms, and compared the number of sources versus the accuracy of the predicted results. And you see that if we are using this NRMS-based dataset construction, we've got much more accurate results overall, or vice versa. If we if we fix the number of sources in the training dataset, then for the NRMS-based data set, we've got more accurate results. Or if we want to get the same accuracy, we can use a much lower number of the sources in the training dataset to get the same accuracy. So anyway, what was done was much better than just naive approach of equidistantly distributed sources. But of course, this approach also had a disadvantage, because in some parts of the model where the model is like smooth enough or almost horizontally layered, we've got pretty much no sources inside the training dataset. So the blue arrow over here represents the area where we've got no sources in the training dataset. On the other hand, if the model is rough in some areas, then this approach would give us pretty much extremely dense set of the sources in this case, in this area, to be used in the training dataset. And it, as you can see on the right, this leads to the effect that this NRMS-based training dataset provides worse results in the areas where a small number of sources are used in comparison with the equidistantly distributed sources, which is not that good idea. So we decided to combine these two measures in quite a naive way. What we did, we constructed the NRMS-based we used NRMS-based distance to construct the clusters, to construct the training data set. I mean, what we did, we started from the beginning of the line, of the sources line, and then add seismograms to the clusters consequently until NRMS-based distance reach the prescribed limit from the previous approach. And however, if the number of seismograms in the cluster is small enough, it's like less than some limit, we just increase the NRMS-based distance limit and go to the step 2. So this allows us to use sparser that the data sets where the model is rough enough because this data does not actually give us any profit. And we did this. We applied this approach to again to this like model, which is called one-hour model, and compared with the previous results. So the table on the top with the equidistantly distributed sources, represent the case when we use the equidistantly distributed sources to generate training dataset. Then in the middle, it's what was done based on the when we generated the training dataset using NRMS-based metrics, and then the last one is the new approach where we try to combine these two measures in a quite naive way. Anyway, even this naive way of combining the approaches based on two different metrics gave us quite a nice profit. However, we only have 2 points. So on this graph, this black guy over here on the plot represents what we obtained. And of course, as I told, it was a kind of naive way trying to combine different measures to construct the to optimize the training data set. And Elena Gandil told you about more advanced approaches based on the global sensitivity analysis of the results and trying to construct the more or less mathematically formal algorithm to combine these measures. And I hope next year we'll present it in more details and in more mathematical details. Anyway, it can be seen that the problem of optimization of the data set can be solved and can provide us much more promising result than just using equidistantly distributed sources in a very, very simple and naive way. So that's pretty much it. Thank you for your attention.
Thank you, Vadim, for your presentation. Any questions, comments, please? Nobody want to say anything or ask anything. Okay, so thank you again for your presentation. Now, as I understand, the second presentation is also yours, right?
Yeah.
Okay, please start.
And you can see it, right?
Yeah, we see.
Okay, so once again, good afternoon, everybody. So this talk was supposed to begin by Tatiana Khachkova, but she's not available. She doesn't have access to internet right now because she's on vacation. So this research was done in cooperation with our colleagues from Tatneft, from Tatarstan, and this was the attempt to show them how the digital rock physics can help help them with their petrophysical research, with their petrophysical analysis of the core samples. And the idea is the following. So what is the main factor which preserves the digital rock physics from widespreading in the industry? And the problem here is that what what we can really do in digital rock physics. We can relatively fast measure absolute permeability. We can easily measure the porosity factor, like specifically like electric resistivity, diffusion coefficients, and something like that, elastic coefficients, and do it quite fastly. On the other hand, if we're talking about digital rock physics and its application, it goes to like two-phase flows, as I presented before, and stuff like this, which is more like research oriented. It cannot be distributed. It cannot be reproduced, well, widely used in the industry, because such simulations require quite enormous time and computational resources. On the other hand, if we're talking about simple basic parameters of the rock, like absolute permeability or elastic model, we expect doing this very fast and cheap, in a very fast and cheap way. However, if we're talking about the available samples right now, CT scans have the size of like 4,000 to 8,000 points, voxels in each direction, and this cannot be done. And even estimation of absolute permeability or something like electric resistivity cannot be done using like standard equipment available in a rock physics lab. It requires clusters, and it requires high performance computing, and indeed no one in the company would provide such equipment for the rock physics experiments. All such equipment are usually busy under the seismic processing tasks. So we need something which can be available for the rock physics guys. And the idea here, and the idea here that the main thing here is that we do not really need to know particular value of I don't know, permeability or electrical resistivity of one single sample, even though the sample has a huge size in terms of voxels. Its physical size is about like 2 millimeters by 2 millimeters by 2 millimeters, and it definitely represents pretty much nothing if we have only one single number, or like only one single tensor of permeability tensor or electrical resistivity tensor. So what we suggest to do is a bit different thing. So, okay, let us consider just the simplest case. If we want to estimate the absolute permeability, we've got to solve Stokes equation, which is presented like over here with the boundary condition. If we solve it and then compute the flux and then estimate, and then we can estimate the absolute permeability like this. So, but the problem here is that we need to solve the Stokes equation, which requires solving the system of elastic linear equations. And this is a saddle problem, which is quite not that good to solve numerically. And we face up with like different problems coming from pure math to high performance computing, because we cannot do it using a single machine for a large scale problem. This is how we can do it. These are formulas. Okay, and then we finish up again with the estimation of the computational resources. If we've got the CT scan of the size of up to 4,000 voxels in each direction, we would need up to half a terabyte of memory just to store one parameter, just to store a model, just to store pressure, or one of the three components of the velocity. So finally, if we sum it all up, we'll finish up with several terabytes of RAM needed to solve the problem, Plus, we need to store some additional parameters if we are using like Krylov iterative methods, Krylov-based iterative method to solve like Poisson equation, for instance, over here. So the typical approach to solve such a large-scale problem is to use domain decomposition and MPI technology to parallelize solvers. But if we are talking about solving the system of linear equations as we need it, if we solve, I don't know, Poisson equation for to estimate electric resistivity, or to solve Poisson equation to predict pressure in projection-based methods, to solving Stokes equation or Navier-Stokes equation. Parallelization of the linear algebra, of the solvers of linear algebraic equations is very has very low scalability, and it's very computationally inefficient actually, and whatever we do, I mean, it takes quite a huge amount of computational resources and time. So the idea, on the other hand, the sample is extremely heterogeneous, but well, it's heterogeneous at the micro scale, but it's supposed to be statistically homogeneous, and the idea is that we don't need to solve the problem for such a huge sample, but let us do it in a bit different way. Let us completely decompose the sample. Forget about like classical domain decomposition, where all the domains are supposed to exchange the data between each other, and solve all the problems independently. Of course, this each small cube would not be might be not even statistically homogeneous, but the fluctuation of the estimated parameters might be not that bad. And let's see what, and then we can